let's first review how to calculate molar mass. Right? Molar mass is easy. So let's calculate molar mass of, let's do Al2S3. And now I should be able to start telling you, find the molar mass of aluminum sulfide, and you would know what the compound is, and you could then calculate the molar mass. Right? This should be something that you should be able to do now. So that's where we're heading. Okay, that's where we need to be getting to. We need to start knowing those compounds and knowing how to name them and form them so that I can just say, find the molar mass of aluminum sulfide, and you do it. Okay? Okay, molar mass, we're looking at the mass of 1 mole of this molecule. We get these molar masses from the periodic table. Okay, so what's the molar mass, or what's the atomic mass of aluminum? 27. How many of those aluminum molecules do we have? Okay, we have 2 of them. What about sulfur? What's sulfur's molar mass? 32, and we have how many of those? Okay. So we take this multiplication, then we add them together, and we get the overall molar mass of this molecule. Okay, so 27 times 2 is what? And 32 times 3 is... We add those together. Right? 150? Is that right? Okay. 150 grams per mole. These are types of things that, calculating molar mass, this will be on your final. So these are things that you maybe want to brush up on here a little bit.
Are you saying that we should start memorizing?
Sorry. I gotcha. 150 is our molar mass here. Okay, so we need to do a couple of these to practice. Let's do a couple.
I'm good.
You think you're good now? All right, let's try this one then. Calculate your molar mass of... First of all, tell me the name of this molecule and then calculate molar mass. All right, so tell me what you got for molar mass of potassium chlorate. 122.6. Okay. If you didn't get that, do you have an explanation as to why, or do you have questions? Yeah, Michael.
I think it's rounded differently. I got 122.5.
That's fine. No big deal.
Do you do all?
Okay, let's try this one.
How do we do the thing with like the Avogadro number?
We're going to go over some of those.
Oh, right.
So let's try this one.
What were the ones where like the specific multiplying?
What do you do with this 2 right here? Yeah, so we have 1 calcium, we have 2 nitrogens, and how many oxygens do we have? 6. We have 6 oxygens. This 3 and this 2 do not get added together, they get multiplied. Okay, just like if there was a 1 here for nitrogen, you wouldn't say we have 3 nitrogen molecules, would you? You'd say we have 2, right? Because 2 times 1 is 2.
Yeah.
All right. All right, tell me what we got for molar mass here. 164 point anything or no? No. Grams per mole. We know how to calculate molar mass. How do we convert between moles and grams? Do you remember?
Yeah, you do a little T thing.
Yeah, we use our T chart. Okay, so let's go back to
The moles, so you're going to have moles right here, and you're going to have moles diagonal.
okay, let's say if I want to go from moles to grams. Okay, if I have a certain number of moles of something and I want to go 2 grams of that compound. Okay, I'll put moles up top. Write what you know. Then moles goes where?
Bottom. And put a 1.
Moles always gets the 1.
Yeah.
And then what goes up top?
Whatever the grams is.
Yeah, the molar mass goes here. Okay, so we'll just put molar mass here.
Yeah.
Yeah. Okay, so let's say that I have 0.84 moles of magnesium chloride. And I want to find out how many grams that is. I want to find out how many grams magnesium chloride would be. So before we can do anything, we need to figure out the chemical formula for magnesium chloride.
MgCl2.
Yeah, exactly. Good. MgCl2. Because magnesium is +2, chloride is -1. We cross down our charges, we make our compound. That's it. Okay? MgCl2. So I know I have 0.84 moles of that substance. When I go to make my T-chart, the first thing I do is write what I know. 0.84 moles. Okay, then I make my T. And I put moles where? Bottom. Moles of MgCl2. And I put grams on top. Which one gets the 1? Moles gets the 1, so it goes on bottom. Moles always gets the 1. How many grams are in that? What's the molar mass of magnesium chloride? 95 point.
I got 94. Should I?
Okay. So 95.3 is the right molar mass. What do we do to then find grams? Exactly. Multiply across the top, divide by the whole bottom. So we take 0.84 times 95.3 and we get...
79.
Make sure you do the 0.84. That's going to throw you off. So you got what? 80.05 grams. All right, 80.05 grams. So is that, look at our big picture here. Does this number make sense? Is it less than what 1 mole of that substance would weigh?
Yeah.
Yes. And that makes sense because we started with less than a mole. Okay. Is this all coming back to you a little bit now? Yeah. Okay. So what if I'm given 93 grams of iron oxide?
And grams goes in. We're supposed to figure this out.
Yep, we're going to do the math. Okay, this is iron what oxide? Iron 2 oxide. Remember, this is iron 2 oxide because oxygen's -2. Iron can take on multiple charges, so the name of this molecule would be iron 2 oxide. Okay? Just so we review our naming all the time. So we'll go ahead and write what we know. 93 grams of iron 2 oxide. We make our T. What then goes on the bottom if I want to go from grams to moles? Because that's what I want to find here, is I want to find number of moles.
The mole mass.
Yep, good. Grams goes on bottom and moles goes on top. Moles gets the 1, and you're right, the molar mass goes on the bottom. So who has the molar mass calculated?
71.85.
71.85. Uh-oh. 127.6. Okay, so 127.7.
Did you do FE2?
No, it's F.
No, it's not FE2. Mm-mm.
It's Fe1O2.
Okay, it's iron 2.
Like how many?
Okay, so that's
Yeah, this is, I don't want you to get confused by that. If you write out the name of this molecule, it looks like this. Iron 2 oxide.
and that's because the oxygen has a charge of 2, which makes the iron have a charge of
Yes, exactly. So the subscripts is what you go with for molar mass. So it's just iron 1, oxygen
2.
1.
It's just you saying it.
Okay.
It's not
Exactly. That's just me saying it. That's not me saying the chemical formula. Okay? Sorry, I didn't mean to confuse you there. So iron 2 oxide, this is how it would be written. That's its formal name. Its chemical formula is just FeO. So that's what we calculate molar mass based on, is chemical formula. Okay?
Wait, so they're neutral
Now tell me what the molar mass is. 71. 71.8. Let's round there. Okay. So if I want to find out total moles, I multiply across the top, I divide by the bottom, and I get what?
1.3.
1.3. What's my units?
Moles
Good.
of FeO.
Yeah, moles of FeO. Good. Or iron 2 oxide. Okay, so does this answer make sense? Did we start with our molar mass greater than 1 mole of it?
Yeah.
Yes, so we should be getting an answer of greater than 1 mole. Okay. Oh, my handwriting is rough today. I'm really sorry. So we're looking to find out what percent of nitrate is made up of nitrogen, or what percent of a particular compound is made up by one element. Okay. So that's what our overall goal here is to look at percent composition. In order to do that, we need to start looking at mass of a particular compound and what its element's mass is in a particular compound. Okay? So we're going to look at an example they give here in the book if you want to follow along. It's on page 241. Okay, if you want to follow along, that's fine. We're going to work it through together anyway. We're going to look at, down on the bottom it says, given 33 grams of this big, huge molecule which is ibuprofen, we're going to try and determine how much of that molecule is made up of carbon, what the mass of carbon is within that molecule. Okay? So we need to first look at this big, huge molecule right here. C13, H18, O2. Okay, this is a molecule of ibuprofen. Okay, this medicine that we use, and it's common to us, this is one molecule of it. And this is what it's bonded. It's very complex. There's a lot of parts going on to it. But we're going to look at this particular molecule. And what we need to do is we need to look at if there's 1 mole of this substance, if we have 1 mole of this, 1 mole of this whole compound, how many moles of carbon would there be there? If we have 1 mole of this whole substance equals how many moles of carbon?
Well, it'd
It'd be
be 13.
13. Okay? And this is why it's 13. For every 1 molecule of that compound, there's 13 carbon atoms within that. Okay? So for every mole of it, that means there's got to be 13 moles of carbon alone. Okay? I know that seems a little counterintuitive, like you can't have more than what you say you have, but you have 1 mole of the compound. We're looking at how many moles of just carbon atoms there are. So there's got to be 13 moles of that, okay? Because for every one of these elements, every one of these compounds, there's 13 carbon atoms within that compound. So if there's 1 mole of the compound, that means there is 13 moles of carbon. So we need to start looking at these subscripts as kind of a ratio here. As if there's 1 mole of this substance, how many moles of oxygen is there? 2. And there's 18 moles of hydrogen. Okay? So although we only have 1 mole of the compound is made up of many of those elements. So that's why we need to start thinking of it in terms of a ratio. Okay? So we're going to start looking at molecules, and we're going to start looking at individual atoms or elements within molecules. That's our goal. So we want to find the mass of carbon if we're given 33 grams of this substance, C13, H18, O2. Okay, we're given 33 grams of this substance, and we want to find out how many grams of carbon that is. That's what we're looking for. Within that amount of substance, we want to find out how much of that is made up of just carbon. That's our overall goal here. So we're going to walk through the steps to get there. First of all, the first thing we need to do is convert to moles. Okay, we need to convert this molecule to moles. So we're going to write what we know. 33 grams of you don't have to write the whole molecule if you don't want. This is kind of a bigger one. So 33 grams of ibuprofen, and we want to go 2 moles. So calculating this molar mass is still simple. It's still the same process. You're going to take carbon, and you have 13 of those. You're going to add it to 18 hydrogens and add it to 2 oxygens. So go ahead and do that, and we'll find the molar mass here. Because of ibuprofen. What did you say?
206.
206.
No, it's 206.
Okay, we'll just stick with 206.3. So we want to find out moles of this substance. So how do we do that? We're going to
Divide.
multiply across the top, divide by the bottom. So take 33 divided by 206, and we should get,
6.16.
you should get a small number, like a point. Oh, I thought you said 6.16. Okay, 0.16 moles. Okay, that's because moles is what's left on top. Remember, we canceled grams, and we end up with moles, so that's our unit. So this is how many moles of this substance that we have. Okay, we were given 33 grams of it. This is how many moles we have of it. Okay, now we want to convert from moles of ibuprofen to moles of carbon. Okay, so I'm going to go ahead and get a new slide here. So right now we have 0.16 moles, 0.16 mole of C13H18O2. And we want to go to moles of carbon. Okay, because our overall goal is grams of carbon, and moles is kind of our middleman. That's how we do all of our exchanges between substances. Okay, moles is our middleman. We have to be there. So we're going to go 0.16 moles, and this is of ibuprofen, so C13H18O2. And we want to get rid of moles. This is of our big molecule, so C13H18O2. And this is where it gets a little bit tricky, okay? So we want to go from moles of this big substance to moles of carbon. So moles of carbon is still going to go up top. So now, how do we determine which one gets the 1?
The bigger one.
Why do you think so?
Because there's more.
Because it has to cancel out.
That's not the reason, but there's the ibuprofen molecule does get the 1. Okay, and I'm going to tell you why. We talked about earlier that for every 1 mole of ibuprofen, there's 13 moles of carbon, right? We know that just from looking at our chemical formula, correct? Exactly, so we're going to put a 13 up top. Okay, this is telling us that for every 1 mole of ibuprofen, there's 13 moles of carbon. Okay, so when it's a mole-to-mole step in our T-chart, we can't automatically guess which one gets the 1. We have to take a look and take a step back and see which one should actually get the 1. Okay. Tell me what you get then for moles of carbon. 0.08. 2.08. Okay, that's moles of carbon. That's how many moles of carbon are then in 33 grams of this ibuprofen molecule that we're looking at. Okay, 2.06 moles of carbon. Okay, are we on the same track right now, you think? Following along? Okay, so right now within that 33 grams of ibuprofen that they gave us, we have 2.06 moles of carbon. Our last step then is to convert from moles of carbon to grams of carbon. So we have 2.06 grams of just carbon, and we want to convert from grams of carbon to moles of carbon. So now when we're looking at grams to moles, moles gets the 1. Okay? If we're looking to go, I said it backwards. You're right. We don't have 2.06 grams. I'm sorry, I didn't mean to confuse you.
2.8.
I can't do anything right on this slide. Let me just start this one over. Okay, 2.08 moles of carbon. There we go. Okay, nailed it. Okay, so now we want to put moles where? On the top or the bottom? Bottom, good. See, that was really just a test for you guys, and you passed. Ha. Okay, so now since we're going between grams and moles, moles does get the 1. How many grams are in 1 mole of carbon? 12. Okay, and we get that from the periodic table. That's our molar mass. So now we take 2.08 times 12, and we get 24.96, or just 25 grams. Okay. Does that match what your book has on page 242? It says 25 grams of carbon. Okay, we did it. So what this is saying is that out of that 33-gram sample we took of ibuprofen, 25 grams of it is pure carbon. That's what we just calculated. That out of that system, we took this compound, we took a random number of this compound, and we were able to calculate how much of that was pure carbon. Okay, we just did it. That's it.
How much is 33 grams of?
Okay, so we're gonna walk through this problem, and we're gonna do it. Would you rather do one long T-chart or split up ones? One long. Okay, so listen up, please. We're gonna walk through this with one long T-chart here. So if we're given 190 grams of aluminum sulfide, and we want to find the percent mass of aluminum. So we first of all always write what we know. 190 grams Al2S3. We're going to make our T-chart here. I want to go from grams of aluminum sulfide to moles of aluminum sulfide. So grams Al2S3, and I want to go to moles. And which one gets the 1 here?
Mole.
If we're in grams and moles. Moles gets the 1. What's the molar mass then of aluminum sulfide? 150.3. Okay. And then if I want to go between moles aluminum sulfide and moles of aluminum, okay, so in 1 mole of aluminum sulfide, how many moles of aluminum do we have? So 1 mole of aluminum sulfide equals 2 moles of aluminum. We know that because it's got this 2 subscript here. Okay, does that part make sense? That's the tricky part. Okay, we've got to see that in 1 mole of aluminum sulfide, there's 2 moles of aluminum atoms. Then we go from moles of aluminum to grams of aluminum. And moles gets the 1 because we're going between grams and moles. And the molar mass of aluminum is what? 27.
So you don't times it?
So no, we don't put in Al2 for our molar mass. We've just used aluminum. So we multiply across the whole top, divide by the whole bottom, and I got 68.4 grams. Okay, good. So that's how many grams are in 190 grams of aluminum sulfide. If we want to find out the percent mass, we take 68.4 divided by 150, and we get, but divided by 190. 190, and we get about, should be somewhere around 30? 36.
36. I just forgot to add an aluminum. That's what I got.
Oh, on your original molar mass? Okay. Good. Very good. Okay, so your original assignment was page 230 what? Page 235, number 1 and 2. And then to add to that, I want you to do page 244, numbers 2, 3, and 4. Okay, on the section review, page 244, numbers 2, 3, and 4. 2, 3, and 4. And for number 4, it asks you to take it a step further and ask you how many molecules are in a certain number of grams. You just go back and see how to do your Avogadro's number. It's easy, okay?